In the most interesting panel, Ed Chi and Sergey Levine and others spoke about how agents can be improved and made more human-like, or in other words, also support humans better. Sergey spoke about offline reinforcement learning, which is really kind of like inverse reinforcement learning, where instead of setting the goal, setting a reward function, and then enticing a behavior by the agent, you are having the agent interact with humans, and then you infer from the interaction with humans what the reward function is until the agent learns, and then in future interactions does better. So multi-turn RL, which is what he was talking about, is kind of like a summary of his work in reinforcement learning offline. In one of the papers that he spoke about, he introduced a benchmark for that. I think Sergey has been very vocal on offline reinforcement learning and inverse reinforcement learning because of the difficulty of reward function design. He also said something very interesting. He spoke about the idea that when we train agents, we actually want to have suboptimal behavior. So ideally, let's say we would want to have a lot of conversations between people, and a lot of them maybe also not so good, with bad outcomes, so the agent can learn what's good, what's bad from the outcomes. So let's say if I have, let's say, a store clerk which acts very nasty with customers and they leave, and then the same clerk is very nice to customers and they buy, that way the agent can learn much faster how to behave in order to entice a buying. Ed Chi from Google Deepmind, he was very interesting. I think he spoke with us for hours afterwards. Interesting character. I think his main contribution was to talk about the new paradigm shift from retrieval-based AI, like Google, of course, towards mind-based AI, where we actually interact with a mind. We interact with something that thinks and researches and does reasoning. And I think the ultimate Turing test now is not whether we understand the language of the person or the thing. The ultimate Turing test is, can we get annoyed at it? In other words, we tell the thing, find me the best restaurant in Palo Alto, and then it answers something, and then I go there and it's not good, and then I would say, hey, why did you recommend me this? So there's a human-like relationship, because this feels like a mind and acts like a mind because it reasons. Now, how does it do that? Of course, for that, we need all the tech that we discussed before, the offline reinforcement learning by Sergey. We need MCP, we need Ember, we need the reliability technology that Ion and Mate are introducing. So I think that really summarizes very nicely most of the event that I attended yesterday at Berkeley. A shout out also to Dawn Song, the organizer, and I think she's the head of RDI, research for distributed intelligence. It's absolutely astonishing to be part of this right now, even as a spectator, which unfortunately I am right now. I'm not really involved in the actual development of these machines, but as an investor and spectator, an interesting party, I'm just very excited to be part of this, to see how a whole community is growing and developing new ideas and iterating around concepts. For example, in the conversation with Etchi afterwards, after hours, I mean, he really spent a couple of hours with us, about 30 of us, talking about what it means to be exposed to a mind, how our minds will evolve with those minds increasingly, how I spoke about, I brought up a couple of things in that conversation. One is how do we do eval in a world where Move 37 is possible? So when machine intelligence starts outpacing our own intelligence, at least within the frameworks that we care about. So for example, like in AlphaGo Zero, we cared about winning the game. And the machine was better at winning the game by doing a move that the experts deemed as not right. And then it won. So how do we evaluate models that seem to be better at reaching the goals that we set them? That's, I think, an open problem. And I think on top of my head, I could only think of simulation. I think simulation is going to have to play a much bigger role which is kind of like what Sergey is talking about with offline reinforcement learning, which is kind of like what simulation is, right? But what you're doing in offline reinforcement learning is you simulate interactions with let's say nature or with real people. Tesla simulates the interaction with the traffic in Austin through a simulation, and therefore we can have many turns in a reinforcement learning setting. And then if we have real data where we actually learn how the machine behaves given its setting, then we can implement that in the simulation and fine-tune the machine. I think one of the biggest problems with AI, it's not the probabilistic nature of the actual models, it's the probabilistic nature of the input. That's what's so new about this whole AI infrastructure that we're building. Machines in the past have been reliable within the context of their own mechanics and the input that they get. Like a KUKA robot always gets the same input. And if the input changes, it immediately stops working. So if, for example, it's supposed to work indoors and then there's rain, it will stop working or whatever. If somebody is in between the machine and the screw that it's supposed to screw, it will stop working. So that's not the case with this next gen AI. This next gen AI is designed to interact with the environment, and therefore that's the probabilistic nature, and that's what's so crucial. And I think whether it's Matei Zacharias' reactive optimization, whether it's Ion Stoica's reliability questions, Sergey's offline reinforcement learning, and Etchi's interaction with the mind, they're all the same type of questions, which is how do we interact with an intelligence that is trained by definition to act based on a probabilistic environment, and therefore has also probabilistic outcomes, and therefore can annoy us, can enchant us. But fundamentally what we want is, of course, we want it to deliver results. We want it to be safe within a certain context. I think safety is a loaded word because it's being mainly used right now as a deterrent for technology as opposed to actual advancement of technology. So that's unfortunate. But I think as we summarize this event, I think what the biggest takeaway for me has been that we interact with minds, that the minds need to coordinate with each other, and that we need to learn better how these minds interact with nature, and we need to build simulation engines to facilitate that. Thank you.